Hello everyone. Today we are going to discuss an important topic from class 11, that is the projectile motion. Actually, in your syllabus, you have read the chapter that is a motion in a plane. A portion is there, and today we are going to discuss an important example of motion in a plane with constant acceleration, that is a projectile motion. Actually, this topic is very important. If you are actually for the school level exam, its topic is very important, and as well as many questions are coming from this topic in the NEET exam. Okay, so in this video, I'm just going to discuss some of the important portion of this chapter. That means some important derivations, some important formulas of this portion, and after that, in the next part, we will actually solve some of the previous year questions from NEET exam. Okay, so without wasting the time, I'm just going to start. So first of all, as I have said to you that important example from the motion in a plane is a projectile motion, and with that the one important word which I use that time, that is a constant acceleration. So you can say that this motion, actually when an object is in projectile motion, it will have a constant acceleration. Okay, so what is projectile motion? First of all, I'm going to give you some basic example. After that, you are going to learn about this thing more clearly. Okay, so first of all, suppose you are standing on a ground. Okay, this is the ground and you are standing on the ground, and you are playing some football or basketball, something like that. Okay, and you want to, suppose you are playing a football. Okay, so this is the football and you want to kick it. Okay, so what you are going to do, you want to kick this football by okay, so obviously when you hit this ball, kick the ball, that means you will apply, you will give this ball a certain initial velocity, and you will kick it at a certain angle. Okay, that means the initial velocity with a certain angle, you just kick it, kick the ball. So after that the ball will follow a path like that. Okay, this is the common example, you know about it. So this actually, so that means when an object is thrown, that means in this case this is the ball, so we can say that when an object is thrown with a certain initial velocity at an angle, it will follow a curved path. It is following the curved path or curved trajectory. That means the following the curved path. This path is called this motion. That means this motion is called projectile motion, and the object, this object which is thrown, this is called projectile. Okay, this is the first example. So simply this is your projectile motion. Another example, you can say, suppose a basketball player. That means suppose you are standing here, you are throwing a basketball, and there is like this kind of arrangement is there, and you are actually throwing the ball in a certain direction. That means with some initial velocity and at a certain angle. This, that means after that, after giving the initial velocity and to the ball, and after throwing it in a certain direction, it is going to follow a curved path. Okay, this path, this trajectory is actually the projectile, the trajectory of the projectile, and this ball or the basketball is called your projectile. Okay, it is clear. So these are the examples. So in case of, if you want to any other type of example, that means in which case we are actually discussing the projectile motion. So you can say that in case of intercontinental ballistic missile, you know what is ballistic missile? Ballistic missile. So in case of ballistic missile, actually suppose some intercontinental, or suppose a war is actually there, and one country want to throw a missile to another country. Actually, obviously we are not, supporter of the war, but just let us discuss. So suppose there is some from this place, a missile, ballistic missile is actually, one country or one portion is going to throw it to a particular target. This is a target. Okay, so actually what will this country will do, it will throw the missile at a certain velocity and at a certain angle, so that it, after traversing a particular path, it's actually going to hit this target precisely. otherwise there will be a problem, right? So in this, all these are all the examples of the projectile motion. Okay, now one thing you have to be more clear about this thing. That means suppose you are going to throw this missile to this target at a, and you have given a certain velocity and certain angle. So obviously if you vary the u or theta, that means the path will be different like this, or path will be different like this. That means sorry, that means if you change the velocity or the angle, the missile will miss its target. Okay, so that means before targeting, that means before throwing the missile to the particular target, you have to be precise. You have to fix the value of u and theta such that suppose you want to throw the missile to the target at a certain, after a particular interval, at a certain time. Okay, otherwise the distance will remain fixed. That means you have to keep in your mind that if you want to hit a target by your missile, that means you have to fix your u, theta, everything such that it will precisely, go there. So to know how the missiles are actually, they are handling, how the missions, this type of missions are completed. So for that, uh, obviously they have to know the value, the distance of the target, everything. Okay, so for this we actually require some type of some actually formulas, some things, some formulas. That means suppose this is the missile and this is the target, and if you want to hit it, so obviously you have to know what is the total time taken by your missile, what is the range, that means the distance between the throwing point and the target, that means the range, or the particular height. That means this type of things should be clear before throwing. Okay, so because of that, today in our chapter, in our syllabus, from the projectile motion, what is there, we have to calculate the total time taken by the projectile. That means the projectile, suppose this is the projectile and it is thrown and it have traversed a certain car path. Okay, that means that this is the parabolic path. So what is the total time taken by this projectile to complete its journey? That means we have to calculate the t, and that is called time of flight, right? Sorry, time of flight. Okay, after that, this distance from this point to this point, this is, that means the distance from of the ball from the initial position to the final position, this is the range. Okay, so we are going to calculate the range of the projectile. And suppose after throwing the ball it attained a certain height, a maximum height, after that the height again decreases. So we are going to calculate the maximum height of the projectile. Okay, so we are going to discuss this three portion today. After that, we will be discussing the other related portions, important portion of this topic. Okay, so before discussing the projectile motion, before discussing these the formulas for t, r and h, and we have to actually know some of the important points of the projectile motion. So I am going to take an example. Suppose this is the, this is the projectile. Suppose this is your projectile and you are going to throw it, and you have given it a certain initial velocity. Suppose initial velocity, that is u, and the angle. Okay, and the angle is your theta initial. Okay, and after this it will travel like this. This is the final position. Okay, so first of all, the point from which the projectile is thrown, we actually take this point as a point of projection. We are taking this as a point of projection. Okay, and the velocity u is called the initial velocity of the projectile. Okay, and what is theta? Theta is your angle of projection. Theta is your angle of projection. This is clear? Okay, now the starting point and the final point, this distance is, I have discussed you, that is, this is the range of the projectile. What is r is the range of the projectile. The maximum height, that means from the ground, you can say this height, this is the maximum height of the projectile. So what is h? H is the maximum height gained by the projectile. And what is t? T is the time of flight, that means the total time taken by the projectile flight. Okay, now actually you can see that in this case, so that means this projectile is going upward, and after some time it again reaches to the ground. So obviously height variation is there. So we, and also you know that with the height, the value of g actually varies, but we will consider that the value of g, okay, acceleration due to gravity, is constant throughout the journey of the projectile. That means the value of g is 9.8 meter per second square. That means at the time of discussing the projectile motion, we will assume that the projectile is actually near the surface of the earth, and the value of g is remains constant, that means 9.8 meter per second square. That is why at the beginning I have said that we are going to discuss important example of project motion in a plane with constant acceleration. That means the value of g in this case is constant. Okay, and another thing which we have to assume that in the case of discussion, that is the air resistance. Okay, air resistance is negligible. Air resistance is negligible in our case. Okay, these two are assumptions, you have to keep it in your mind. Okay, and now, so you can see that the motion of the projectile actually it is taking place on a plane, right? So we can have the two axes in this case, because it is actually taking place in a plane. So we can take this as our x-axis, and this is our y-axis. So clearly, if we have two axes and the motion is actually taking in a plane, that means we can actually take all the values, that means the velocity part or velocity part in two perpendicular directions. That means we are going to separate the things in case of two in actually two parts. One is along y axis and one is along x axis. Like suppose, what is the initial velocity? Initial velocity is u, and if you resolve this velocity into two components, so obviously along x-axis your value will be u cos theta, as you know, you have did in this portion in your vector chapter, and along perpendicular direction, that is your u sin theta. So what is about the initial velocity? U, in case of x-axis, u will be u cos theta, and in this case u will be u sin theta. What is about the acceleration part? So I'm just writing a for acceleration. So in case of x-axis, obviously the particle is moving along the x-axis, and you know the acceleration due to gravity, the direction of g is downward direction. So in case of x-axis, ax is 0 and ay is equal to g. Actually, we will take g as minus, because in our case we are actually taking the upward direction. When we are using the vector quantities, we will put plus sign if the direction is in the upward direction, and we will be putting the negative sign if the object is moving in the downward direction. And as you know that the direction of g is always in the downward direction, so I have used the negative sign here. Okay, it is clear. Okay, this is about the acceleration. So u and a is clear. Okay, so this is all about the introductory portion of the projectile motion, and now we are actually ready to calculate for the value of r, h and t. Okay, these are very simple, it will not take too much time. Okay, so first of all I'm going to calculate the time period. Okay, so give a heading, time of flight, not time period, sorry, time of flight. So now I am going to calculate the time of flight. So there are two ways to calculate. First of all, so you can see that this is your projectile motion, this is your path of the projectile motion, the initial velocity of u, and you have made the notes I think as well as from my video. So it is clear that first of all, if we take the y-axis only, okay, I'm taking the y-axis only. So if I am taking the y-axis, so you can see that the initial velocity is u y is equal to u sin theta. I'm using the positive sign because the direction of u sin theta is in the upward direction. Okay, the acceleration ay is equal to minus g. It is also clear to you. Okay, and Suppose the time, okay, this is the total journey of the projectile, this is the total journey, and this is the highest point, this is the maximum point, right? Maximum point. And you can see that when you are throwing the particle with a certain velocity at a certain angle, the velocity along the y axis first of all, the value is going to decrease. So the value will going to decrease, and the value of uy becomes 0 at the maximum point. After that, the value of uy again increases and it will take the maximum value here. Okay, that means the value of the velocity is 0 at the maximum point. And this height is actually capital H. It is clear? And because of symmetry, we can say that the time taken by the projectile to complete the half journey, that means the time taken by the projectile to complete only this portion is equal to the time taken by the projectile to complete the other half portion. Okay, so we can say, suppose let us assume the time taken by the projectile to complete the journey from O to A, suppose the time is T. We just assume the time taken by the projectile to complete its path from O to A is T. It is clear? Okay. And obviously the final velocity Vy, suppose it is 0. That means we are just actually concentrating on the portion OA. Okay. Now can you use the formula? V is equal to, V is equal to U plus AT, right? So what is V? V is 0. What is U? U sine theta. What is A? This is G. What is time? Time you have taken T. So from this you have u sine theta by g. So this is the half time. So what is the total time? That means time of flight will be 2 of t. That means 2u sine theta by g. This is the formula for the time of flight. So you have to remember this point. That means t is equal to, I am just writing here, t is equal to 2u sine theta by g. This is the formula for the time of flight. This is the one way to derive this. Otherwise there is another way. That means if you take the total path, suppose the another case is that again uy, these are the same. Okay, now you can take the total time is capital T, time of flight. And in case of total time, if you are taking the total time, so obviously the total displacement along the y-axis is 0, because initially the particle was on the ground and finally the particle is again on the ground. So what is the difference in height? It is 0. So the total displacement is 0. T is the time taken to complete its whole journey, and ui and ay are same. So can you use the formula S is equal to ut plus half at square? Okay, u is equal to, otherwise without using this thing, one second, without use, okay, you can use this, no problem. S is equal to 0, u is equal to u sine theta, and t is equal to capital T plus half and g minus g. So I am putting the minus here, and t is capital T square. So obviously from this you can take t common. U sine theta minus g by 2 into t is equal to 0. So obviously t cannot be equal to 0. So this portion is equal to 0. So you can get t is equal to 2u sine theta by g. So from this you can also get the formula. Okay. So these are the two methods. So you can use any one of them in case of your exam, and especially you have to, for solving the numerical problems, you have to remember this point. That means t is equal to 2u sine theta by g. Okay, this is the time of flight. The next thing which we have to discuss, that is the maximum height. So what is the maximum height? Now we are going to discuss that. Okay, so the maximum height attained by the projectile. So which one is your maximum height? So obviously this is the projectile and it will follow this path. So this height is your maximum height and the path is OAB. Okay, so if you want to calculate the maximum height, that means again we will take the y-axis in our consideration. Okay, so again uy is equal to u sine theta. Okay, and ay is equal to minus g, and okay, and the formula which you can use, v square is equal to u square plus 2s. You know this formulas. So you can see the journey from O to A. So okay, so we are taking the journey only from O to A. So in case of O to A, you can see that what is the final velocity at A? we are taking only the motion along the y-axis. Okay, so vy is equal to 0. This is u sine theta square plus 2, a is minus e, so I'm putting the minus sign here, and g is capital H. Okay, so what is the formula? 2gh is equal to u square sine square theta, and from this you have got u square sine square theta by 2g. This is the formula. So the second formula is h is equal to u square sine square theta by 2g. Okay, this is the second formula. Now the last one, that is the range. Okay, this is completed. Okay, now we are going to derive the range of the projectile. So give a heading range of the projectile, and we are denoting it by the symbol R. So what is range? Simply that means this is your projectile and this is the final destination. This distance is your R. So if you want to calculate the capital R, that means somehow you have to keep you along the x-axis. So in this case, we are going to take the x-axis and we will take the values of u initial velocity or g acceleration for the x-axis only. So you know what is the initial velocity? This is u cos theta. What is acceleration along the x-axis? It is 0, right? Okay, and total displacement along x-axis is capital R. So you can use the formula S is equal to ut plus half at square. So S is R, U is U cos theta, and total time, obviously in your case T will be total time. That means if you are calculating the capital R, that means the total journey, the total time taken by the projectile to complete this displacement is total time T. That means the time of flight. So at this, in place of T, you are using capital T, 2u sine theta by g, and plus half a. So a will be your ax. So in your case ax is 0, so this term is 0, right? So now you have r is equal to u square. Okay, 2 I will write like this, 2 sine theta cos theta, because I have some reasons because of writing like this. So 2 sine theta cos theta. Now you know the formula that 2 sine theta cos theta is equal to sine 2 theta. Okay, so can we put it here? So we will get u square sine 2 theta by g. This is your formula for the range of the projectile. So the last formula for range, u square sine 2 theta by g. These three are the formulas for the projectile. So it is clear, I think, to everyone. If you have any doubt, you can write in the comment section that this is my doubt, and I will solve your problem. Okay, so time period, you have to remember the formulas for your competitive level exam, for the NEET exam. That time you will not get sufficient time to derive these things. Okay, although they are very easy. So first of all, what is the formula for the time of flight? 2u sine theta by g. What is the formula for maximum height? This is u square sine square theta by 2g. And what is the formula for the range? U square sine 2 theta by g. Okay, so this is all about today's video, and in the next part I will discuss about the path of the projectile and some important points which actually it is not possible for me to discuss from this range part, or some portions are there that I will cover in the next video. Okay, so thank you.